Now that we know how to make a very simple particle simulation by adding a couple of forces, animating their parameters, remember that, and then cloning some cubes on this, because this is just a bunch of cubes. In this video, I'm going to show you how to render your particles and cache them without the use of any cloner. So let me delete this cloner, and without touching anything else, let me go to Redshift and bring up the render view. Now let me go and dock this here on the left and start the render view. And immediately you will see that we get whatever the frame is giving us. We see the particles. Now let me go a bit and zoom in here, and you will see these are little spheres. It's too flat, so I'm just going to go and add a dome light and remove the background. So go down here and remove the background. So now we get a bit of global illumination. Now the little spheres you see here, which have the radius of the particle, more on that later, my favorite tagline. If you go to the particle group and right click and go to the render tags and bring up the RS object, it immediately identifies that this is a particle object, so it will give you the particles tab. But the mode is disabled. If you set the mode to optimize spheres, you're going to get exactly the same result as we get without the tag. And this is pretty much one of the best methods to render particles. It can handle millions and millions of particles quite efficiently. But for now, I'm going to remove this. We are going to talk about this at a later video, and we just get the same thing. Now, one thing I want to focus on now is the way we scrub the timeline when we have a simulation. And the simple answer is we can't really. So if I go here and jump to frame 113, nothing's going to change because the simulation is made in a way that if you go from frame to frame, you're going to get advances in whatever is simulated. If you go backwards and forwards and jump, it's not going to do anything. But you can always rewind and then either play your simulation, and when you stop, it's going to render that frame, or it's going to do some intermediate renders whenever it catches up, or you can scrub one frame at a time, just advance one frame at a time if you want to get to a certain point. But now you can't go backwards. What if you want to go back to frame 50? You have to rewind, press play, stop it, advance a few frames. Anyway, if you want to do look development and you want to do lighting and all that, you assume that your simulation is at a point where it's okay for that particular task. So it's time to cache. I want to turn this off because both Redshift and the simulation system share resources on the GPU. I just want to make it easier because I'm recording my screen and all that. So caching. Go to the particle group and you will see in the cache tab, it gives you the ability to cache the object. So any object that's selected, it will cache it or cache the scene. Now, mind you, particle simulations are part of the same unified simulation core where cloth, soft bodies, balloons, pyro, rigid bodies are based on as well. So if you cache the scene, any of those components are going to cache at the same time. But for now, it doesn't make a difference. We only have our particle simulation. So select the particle group and press Cache Object. This is going to bring up our Save As dialog, our export dialog. And you can see it says here Alembic file export, and the only type we can export particles to is Alembic. Alembic is an industry standard and is fantastic for caching particles and meshes and all sorts of other stuff. Now make sure you put a very, very descriptive name here so you know exactly what you're doing and press Save. I'm going to let this cache in real time. And you can see it's writing to disk and it's simulating and caching at the same time. And I think that's acceptable for this amount of particles. Now, if you scrub, you can see everything you need to see in real time. And the particle group indicates that it's now cached. It has the cache mode on and the path to our Alembic file. So now we can turn on our render view and you can see that wherever we go, we're going to get the appropriate frame. And this is fantastic for look development. Now I can set my camera frames and all that. If I want to do any changes later on, I can go and do them. But as long as I have my simulation at a point where it pretty much is close enough to what I'm trying to do in terms of size, how far the particles are and all that, I can use an initial cache here just to do what I want to do. And that's fantastic. You don't have to throw away the caches. You can do many different caches here. You can just turn this off and cache again with a different name and again and again and again if you want to explore different parameters and so forth. So you can always keep these caches. Now, mind you, if you have millions and millions of particles, these files are going to become big, but Alembic is fairly good at compressing the data. So what we have at this point is the ability to cache our particles and render them, or render them without caching with all those drawbacks. The final thing I want to touch upon before I end this video is just to show you what parameters are available to render. I'm not going to get into them specifically, just show you where they are. Now, if you go to your particle group and go down here where it says cache export settings, these are all the data attributes that are associated to our particle system. And we will find the equivalents in the redshift material. So let's create a redshift material. I'm going to turn off my render view. Let's double click to create a default standard material. Double click on this and let me bring this over here. I don't need these. I'm going to go and bring up my commander, and you can see if you look for user, you have the color user data, the integer user data, scalar, and vector. You don't need the string. These 4 nodes contain all the data that's associated to the particles. All you have to do is just go here where it says presets, and you will find them under the particles flyout. Here we have color, and for the integer we have ID and all that. And there is some sort of tagging what these particles are supposed to work for, although I will provide you with a chart in one of the next videos that shows you exactly which one of these parameters map to which one of these parameters, so that you know how to do this. But in any case, if you're looking for the place to read these and put them on particles, this is where you're going to find them on these 4 user data nodes.